students. Today we have to see about Bohr's model of atom. So before that we know that Niels Bohr was born on October 7, 1885 in, in Denmark. He was also an outstanding soccer player. He worked with Rutherford at the University of Manchester. Bohr's theory became the basis of modern physics, known as quantum mechanics. Bohr received a Nobel Prize for Physics in 1922. Okay, next we go to Bohr's model of atom. Bohr only explained about how the electrons are presented and how the energies are emitted or absorbed, how the electrons can be removed, and how the electrons are distributed by the quantum number. Okay, we go to the lesson that how the model will be presented. In an atom, electrons are, see here, electrons are revolving around the nucleus. This is the nucleus. These are around the nucleus. The electrons are revolving in a stationary circular path. These paths are called orbits or cells or energy levels. Okay, now you know very well that the atoms electrons are revolving around the nucleus in a stationary circular path. These paths are called orbits or cells or energy levels. Okay, next. As long as electron revolve in the same orbit, it does not lose or gain the electron. If it will be, the first cell contains, you see, 2 electrons are here. See here, how many electrons? 2 electrons are here. It will be revolving around the nucleus. It does not lose or gain the energy. Okay, next. See here, you know very well that an electron in a cell can move to the higher or lower energy. Suppose you are removing the electrons or you addition the electrons or gain the electrons, the atom will be gain the electrons by absorbing or releasing a fixed amount of energy. Suppose you give the energy, means we can remove the electron, or otherwise it addition the electron, it loses the energy to addition. Okay, next we go here. See, the orbit or cells are represented by, see here in this picture, it contains the first cell named as K cell, that is n is equal to 1, and the second cell L cell, n is equal to 2, and the third cell M cell, that is denoted in N3, and the fourth cell N cell, it will be going on KLMN, like that. It will be represented by the KLMN F, like that, or the numbers that N is equal to 1, 2, 3, 4, etc. As we move away from the nucleus, the energy of the orbit constantly increases because the electron will be holded by the nucleus. It will be very stronger. Okay, the maximum number of electrons that can be accommodated in the energy cells, each and energy cells, you see, K cell, L cell, M cell, N cell, these are energy levels. It contains electron. How many electrons in each and every cell? It will be denoted by 2n squared format. You know very well, if it will be first cell, how many electrons will be accommodated, we can calculate. N is equal to 1. You substitute the value, n is equal to 1. 2 into 1 square equal to 2 into 1 equal to 2. So first cell contains how many electrons? 2 electrons. Suppose you take second cell, you put n is equal to 2. 2 into 2 square equal to 2 into 4 equal to 8. So second cell contains how many electrons? 8 electrons. Like that it will be going on. We can identified how many electrons maximum will be presented in the energy levels by this formula 2n squared. Okay, when an electron absorbs energy, so we come to the next stage. When an electron absorbs the energy, it jumps from lower level to higher level. When an electron returns from higher energy from one cell to another cell, that is, it will be comes from L cell to K cell, means lower energy level, it gives off energy. Okay, next you know very well. So what is orbit? Orbit is nothing but it is defined as the path by which the electrons revolve around the nucleus. Okay, the orbit is closest to the nucleus in the K cell. It has the least amount of energy and electrons present in it is called as K electrons, and so on, which is the successive cells and their electrons. These orbits are associated with fixed amount of energy. So Bohr calls them as energy levels or energy cells. Okay, next you see the atomic model. Suppose, see here, the electrons will be go into the first cell. It will be losses the energy. When electron will be gain, it losses the energy. When you have to remove the electron, it gains the energy. Whenever you give the energy, you can easily take the electrons from the atoms. Suppose it will be fulfilled, you cannot take the electron from the cells because it will be very stable. Okay, it will be given by E is equal to h of the photon is emitted with the energy. Energy will be calculated in E is equal to h of. Okay. Next you see each and every cell I will be given this center point. See here this center point. See here this center point is positively charged. They given positively charged nucleus and neutrons will be presented in each and every cell. The first cell contains K cell, and the second cell is L cell, and third cell is M cell, and fourth cell is N cell. Each and every cells, the K cell contains 2 electrons, and the L cell contains 8 electrons, and the M cell contains 18 electrons. You see, it will be calculated in 2n squared formula. You put n is equal to 2 means n is equal to 2 means 2n squared formula equal to 2 into 2 square equal to 2 into 4 equal to 8. So the L cell contains 8 electrons. Suppose you put n is equal to 3. See here, n is equal to 3. 2n squared is equal to 2 into 3 square. Okay, 2 into 3 3s are 9. 9 into 2, 18. Okay, so M cell contains how many electrons? 18 electron. L cell contains 8 electron. K cell contains 2 electrons. Only K cell accommodate 2 electrons. If there is 3 electron, it will be go to L cell. 2 electron will be accommodated in K cell and another one is go to L cell. Like that it will be filled. Okay. Next we go to next how the energy will be released. See here, it is a ground state, that is first cell. This is the first cell. Suppose you take the electron from the energy cell, you give an energy to the cell, then only it absorbs the energy and emit the electron. This is the postulates of Bohr's model. Okay, next you go to here. What are the postulates? See here, these are energy level. This is nucleus and this is electron. Electron have only certain specific values of energy. Electrons travel in a fixed circular orbits. We no longer believe this postulates. This is the main postulates of Bohr's model. Okay, next we go to the same thing. Uh, Again, I am saying in atom, electrons are revolving around the nucleus in a stationary circular path. These paths are called orbits or cells or energy levels. These are represented as K, L, M, N and the numbered as 1, 2, 3, 4. And the electrons will be maximum electron will be accommodated by the cells is given by 2n squared formula. Okay, as long as electron revolve in the same orbit, it does not lose or gain energy. As we move away from the nucleus, the energy of the orbit constantly increases. When an electron absorbs energy, it jumps from lower level energy levels to higher energy level. When an electron returns from higher energy to level to lower energy level, it gives off energy. Okay, next we see first electron. The electron I am saying how many electrons will be presented. I saw one thing. How the electrons are distributed. See, first cell contains 2 electrons and the second cell contains 8 electrons and the third cell contains 18 electrons. Suppose these cells are fulfilled or awfully fulfilled, it will be highly stable. Okay, next Bohr's model of atom. Electrons revolves around the nucleus in a definite energy levels called orbit or cells in an atom without radiating energy. As long as an electron remains in the cell, it never gains or loses energy. Okay, next you go to limitations of Bohr's model. Uh, One main limitation was that this model was applicable only to hydrogen and hydrogen like ions. Example, helium, lithium and beryllium and so on. It could not be extended to multiple electrons in a nucleus. Discovery of neutrons. Neutrons will be discovered by James Chadwick in 1932, observed when the beryllium was exposed to alpha particles. The same way, in Rutherford experiment, the alpha particles are bombarded with golden foil. The same way, the beryllium is bombarded with alpha particles. The same mass of and protons were emitted, carbon plus neutron. Thus, the neutrons will be presented. These emitted particles carried no electrical charges. They were called as neutrons. It is denoted N10. So, neutrons will be denoted in N. See, N10. This is the mass number and this is the charge. Okay, the subscript 1 represented the mass and the subscript 0 represented its electrical charges. This is superscript, this is subscript. The upward is superscript and the downward is subscript. Okay. Properties of neutrons. These particles was not found to be deflected by any magnetic or electric field, providing that it is electrically neutral. Its mass is equal to 1.676 into 10 power minus 24 gram, that is 1 AMU. In 1920, Rutherford predicted the presence of another particle in the nucleus as neutral. James Chadwick, the inventor of the neutron, and was a student of Rutherford. Okay students, this session will be over. Tomorrow we will meet